We are going to test our aspirin for the presence of a phenol group. Notice that this is phenol with an OL, not a YL. The OL is an alcohol, so it has the OH of an alcohol. There are two different ways to write a phenol group. This part is the benzene ring with its carbons, 6 carbons. It can be written as an alternating double and single bonds, or sometimes we write it with that circle in the middle. It's aromatic, we say. But anyway, so if a structure includes that phenol group, then it will react with iron 3 chloride to produce a purple color. So are we using any compounds that will test positive for a phenol group? Well, our aspirin has the ring, but there's no OH right off of the ring. This OH is 2 removed. That doesn't count. So aspirin should not react. And then the other obvious one, because of the ring, is this one. It has the benzene ring and the OH. So this is our salicylic acid. It will test positive. So if you test your aspirin and it turns purple, maybe light purple, what does it tell you about the aspirin? That it must contain and why would it have salicylic acid in it, your aspirin that you make in class? Probably the most likely reason is that there's unreacted salicylic acid in it. In other words, your reaction didn't go for long enough, and then maybe you didn't, we really don't do anything to wash out that extra. So remember that you're making your aspirin from salicylic acid, and if it doesn't all react, you'll have some left in there. Okay, what if we went to the store and we bought some fresh commercial aspirin? Would we expect salicylic acid to be present? No, and so we wouldn't expect it to turn purple when we tested with iron 3 chloride. Okay, what about if you had some old aspirin? Especially aspirin that's been stored for a long time in a moist environment. If aspirin combines with water in the air, you can get hydrolysis, which will give you back your acetic acid. And salicylic acid. And the salicylic acid is what tests positive. So if you test some older commercial aspirin, it may turn purple because it may have some salicylic acid in there due to hydrolysis. Okay, let's look at some just different compounds to see what we're talking about with the phenol group. If we had an aqueous solution of each of these, which one would turn purple with the iron 3 chloride? This one has the ring, but the OH is too far removed. It has this carbon in between. So this one will not. This one has the ring, the benzene ring, and the OH is right off of the ring. So this one would turn purple with the addition of iron 3 chloride. Last thing we're going to do is we're going to calculate a percent yield. Percent yield compares how much aspirin you made versus how much could be made based on the amount of reactant you used. You're going to take your actual yield And the actual yield is, that's when you weigh out your aspirin at the end of the experiment. That's how you get how much aspirin you actually made. And we're going to divide that by a theoretical yield. The theoretical yield is calculated. It's the maximum possible. And it's calculated based on how much of the reactants you used. And we're going to base ours on how much salicylic acid we use, because we're going to use an excess of the other reactant. So the lab manual will step you through how to do this calculation. It gives you a little setup, and you just plug in the amount of salicylic acid you used, and to get that maximum possible. And then you'll calculate a percent yield. Let's look at an example. So you calculate the theoretical yield to be, this is theoretical, and what is the percent yield if you obtain this much? This is the actual. So it's actual over theoretical times 100. So pay attention to sig figs. Very good.